Good day, all the EGD learners. I really appreciate your attendance in this video. I just want to point out to you that we are busy with the construction of polygons. We did with the previous example, and then also geometrical constructions will be forming part of this session. And the last portion I will talk to you about is the fact that we talk about the constructing of an ellipse. Now, you know, an ellipse, for some people it's like an oval. It's a circle that's flatter on two ends and wider on the other ends. That's basically the ellipse. And the construction of that can be quite complicated because of the fact that we can't just draw a freehand oval and say that is now what we're looking for. We need to find the exact points for that oval, and it has to be perfectly symmetrically going upwards and downwards, left and right, or diagonal. It doesn't matter. So we need to find a method in drawing the ellipse in such a way that it will be perfect symmetric to other sides. Alright, so now the methods I will point out to you. The first one is the concentric circle method. Now if you should take a look at that ellipse pointed out to you on the screen, you will see that the long length of this ellipse must be 110 millimeters, and the shorter ends, the shorter legs, or the shorter axis, it's talking about the major axis and the minor axis. The minor axis, the shorter axis, in other words, must be 75 millimeters. Right, so that's the rule. That's what the examiner or the draftsman's coming up with and saying to us. Those are the sizes. We can't just abruptly draw the oval. We have to construct it. All right, so the ellipse will be, in other words, as follow. All right, so we have to start with our axis. All right, so there we go with the horizontal, the vertical axis, and the horizontal axis. And we know that the short end will be 75 millimeters. So we can go measure by either using a circle, or we can measure it out, of course, and that will be 75 millimeters. So of course your 75 diameter, sorry, no, in this case the 75 radius, so yeah, it's supposed to be diameter. So therefore from that side to this side, according to the dimension, is 75 millimeters over there. And for the big circle, this is also then 110 millimeters from side to side. It's diameter 110 from side to side, so that's going to be 55 radius, in other words, over there. Right, now with any circle, we will basically divide this circle into 12 equal parts, and that we normally do by means of our compass. Sorry, not by means of our compass, by means of our set squares, like you see over here. We take the 30-degree set square on either side, and then we can also flip it over towards a 60-degree and find the 60-degree onto from left top to right bottom, and also the other way around to find 60 degrees. Now if you use your 30 degrees, 60 degrees, you can imagine that this is 30, that is 60, and then that is 90, so it's going to be 30, 30, 30. So we use our set squares in order to, our 30, 60 degree set square in order to find those 12 points. Right, so there we go with that. Now the next step will be basically to find this ellipse. Now remember, the examiner is pointing out the ellipse which has got a long end on the horizontal side. So in other words, that is the long end over here. We said it's 110 millimeters. That is our circles has been set out exactly the way that it's supposed to be. And then from there on top to bottom, it should also be the way that you see it over here, where it was 75 millimeters. The ellipse should, in other words, be able to stand like this, where it's flatter from top to bottom and longer from left to right. So we need points over here and we need points over there where the question marks has been pointed out to us, in order to get the exact specific point of that ellipse. Alright, now the method we're going to use will be as follow. I use my set square, and from out this intersection point on the outer circle, I drop it downwards. Remember, I'm looking for a mark somewhere over here. Alright, and we're going to do the same on that side, so we're going to go find it on that side as well. And now if we take this intersection point of the smallest circle on the same 30-degree line, and I project that line horizontally towards the left, and I'm using this one horizontally towards the right, I will be able to find an intersection point at that point. Now, does it make sense to you? You could have seen the ellipse is basically on the outer parts over there, and then from there on it will go through that intersection point towards this flatter end. So it makes sense in doing so to find those points over here. But here on the bottom, there's also points I need to find. So therefore, again, It went out from the outer circle on the 30-degree line. It went horizontally upwards, and from this point it can go horizontally to the left, and from this point it can go horizontally to the right, and from this point it can go horizontally vertically upwards from that point. So there we go with the bottom part, and the bottom part over there, it's not complete yet, and the top part and the top part over there giving us information over there. Now again, you will see that your next point will be somewhere over here. What have I done? I've used that point by dropping it downwards. So I will use this point, drop it downwards. I will use that point to drop it downwards, this one to raise it upwards, and this one to draw it upwards up to that point. And I've been using this intersection point on the same line now to go from there horizontally to find that point. So of course this one went downwards, so this intersection point can go horizontally towards that point, horizontally to that point. So in other words, I will find those points and these points over here, and then the horizontal points will be from there outwards, and from this specific intersection point at that point outwards to find it over there. The last point will be that one which is already basically placed in this point and at that point, and the first point will be starting there and starting there. So yes, of course, now I can complete my ellipse, and that will give us the perfect points, the exact points. In other words, it's not guessed, it's not abruptly trying to get it more or less into that area itself. You have to work it out perfectly from those horizontal and vertical points, and from the intersection points horizontally and vertically upwards. So that's the ellipse when it stands basically wider from left to right and shorter from top to bottom. Alright, so that is, I believe, what you understand. Now the examiner is asking us to make it stand vertical upwards. In other words, we're going to have 100 millimeters top to bottom, 80 millimeters from left to right. So in other words, radius of 40, a radius of 100 to get the circle. So there we go with the starting position, and we can draw the inner circle and we can draw the outer circle. So there we go with that part. Now I've got my 30 degrees set square. Can you see the way it's flipped around from one side to the other side? And then of course I can also go 60 degrees to other sides on that side to find my 12 points on my circle. Now remember, I'm looking for some sort of, if you can say it that way, ellipse that will stand up straight with the longer major axis standing top to bottom and the minor axis left to right, different to what the previous one is. And again, I'm looking for points or exact points somewhere over here, somewhere there, and also on somewhere in this case over here, and somewhere where the cursor is pointing out to you. Alright, so once I've got this, I need to determine and start up. Right, the first point, there we go with that first point, that is going straight up from top to bottom. So remember, I'm looking for a point over here. I can also go from this intersection point from the inside. I can go upwards and downwards to find that point. I'm not sure where exactly to stop with the line. I can use the same line, in other words, this case the 60-degree line, to find the intersection point at that specific point over there, and then from there draw it horizontally towards each other. Alright, so on the top there we go, and on the bottom there we go. So now does it make sense? Yes. Top should be the end point of the ellipse, and then it will go through there, and now I'm looking for a point somewhere over here. From top it goes to the right. I'm looking for a point somewhere over here. Now remember, I have to work with a 30-degree line. I can't use the 60-degree line to find the points over here. Again, I have to work on the next line, which is this line over here. Alright, so I think you can imagine I went from out that intersection point horizontally. So if I use this one on the 30 degrees, I will use that specific line to go horizontally, that specific intersection point to go horizontally. On the bottom, I will be using that specific point horizontally and that specific point horizontally. And then the inside part, remember I'm working on this 30 degree and on that 30 degree line. On the inside, it will be basically that specific intersection point going vertically upwards and vertically downwards and vertically upwards from that point and vertically downwards on that point. Now we have got those intersection points, and then of course this will be the inner axis of 40 millimeters from the center outwards, or 80 in total, and then it starts rising again to a larger extent on the bottom there. Alright, and that is the steps how to find. Now of course you can imagine I can take this and I can make it a diagonal line on 45 degrees, whatever the case might be. I will still be able to to construct the ellipse in this way, I just need to take my axis, these axes over here, and from there divide my circles into 30, 60, 90 degrees, 30, 60, 90 degrees in order to get this construction. Right, so this is one method in doing so. So ladies and gentlemen, there's also a second method of what I can do, construct an ellipse by means of the 4 center method. Alright, the 4 center method tells me I've got 4 center points. In other words, again, I will have my major and my minor axis of 80 and 100. So there we go with this part over here. That is going to be 80, that's going to be 110 millimeters. There we go from left to right. That's my major axis. This is my minor axis from top to bottom. So that's what we have in that case. Right, so now the first point, the first step. Now there's a few steps, like in history, like in geography, when you have to answer a lot of long questions, and science and all the other subjects. This is also where I have to remember the steps in order to develop this ellipse. Now from this point over here, from A towards C, remember that's my major and minor axis endpoints. So I connect A towards C in that regard. Then I go to point Q, and with my major radius I can construct or strike an arc up to that point, which is called E. That's my next step. From that point I have to project the line downwards, going downwards towards this point. That gives me now a shorter line, and that's what I was looking for, A towards F, because if I work from A towards C, it's going to give me a circle or a semicircle, but that's not the way I was looking for. Now with my next step, I'm going to take this AF and I'm going to divide this into 2 equal parts. You know the procedures in doing so. So that is getting the bisecting point from A to F. How did I got to F? Q to B all the way up to the top, and then the radius from C to E to find this point. So now there we go with the bisecting point or the shorter end, and that will give me on this axis I have already, give me the red dots that you see over there, the one at G, the one at H. Now of course this will be symmetric, so therefore the distance from Q towards G will be the same distance as from Q towards J on this side, and the distance from Q towards H will be the same as Q towards K. Now I just want to stand still for one moment. Don't get confused with the original endings of this. This is 40 millimeters, 80 in total for the minor axis, and the major axis was 110, so it was 50 millimeters from this point outwards and 50 from there outwards, or 100, it's going to be 50 to that side, and 50, or if it's 110, it's going to be 55 outwards, 55 outwards. Now in the meanwhile I've created new points, and those new points, the red dots that you see over here, is from Q, from the center, outwards and upwards and downwards the same in length, and from Q to the left and to the right the same in length. So I've got this line now already. So I'm going to use this. I'm going to use this line now, and also extend it from H through to J further onwards to find a line over there. Alright, and that's also going to go from that point downwards, and from that point downwards towards what we need on this point over here. Alright, once I've got that, I can say now that if I use, remember the ellipse must go not further than this specific point. So if I say for instance, take my compass, put the needle point at D, remember this distance is 40, so it's going to be another 40, and I set my compass on 80 from this specific red point, from the red point outwards, I will get the arc at that specific size over there, not larger than the initial distance that I have to have. So from H outwards, find it over there. I can also use from K downwards towards the size of which I can't exceed. So in other words, this is the 40 millimeters I need there. So I can also go find that line or that point over there. So there we go with that size over there. It's worked from all the way from K down towards not further than this part, because it can't exceed 40 millimeters. I also have got G and J as center points. Right, so that's the intersection point of those lines I've created. From that point I can go outwards, and it's not supposed to extend further than point A, which was, if it was 100 in total, 50 millimeters from the center. So from there it can't go further than that point, so I'll take my compass, put the needle point at G, the intersection point, and then from there on extend it outwards towards A, which is that point over there, and then strike the arc from this point to that point. Now the reason why I've extended these lines is because of the fact that that will give me the end point and the start point of my different arcs that I have got over here. Right, and then the last part of the ellipse is when I take point J, for instance, as the needle point, I extend the compass up to B, which is the same as G towards A, since this is symmetric, and then from that distance use the arc to complete the last part of what I need, in other words, over there, and that gives me the last portion of my ellipse. Alright, so there's a lot of steps that I have to follow, and of course you have to understand the steps that you have to find. The examiner may ask you, or can ask you in the exam, giving you the axis, the major axis and the minor axis, and ask you to draw the ellipse by means of the 4-center method or the concentric circle method. And then you will be able to, you have to be able to know exactly which of the two ones the method will be look like. Alright, so that is concluding this session, in other words, ladies and gentlemen, of the ellipse. 2 methods been shown. Of course there are other methods also that you can follow. These are the 2 methods that will be given to you and be asked for you, and then from there on you have to work things out and roll it out accordingly in that regard. Alright, so yes, ladies and gentlemen, that brings us to the end of this session. Thank you very much for listening, and thank you for paying attention in order to determine the ellipse itself. I hope and trust that you will go through the steps one by one and will be able to answer your questions. I really appreciate it. Thank you very much.